Today we're going to talk about cosine law. So up to this point, we've learned about Pythagorean theorem and the sine, cosine, tan ratios, which unfortunately only work for triangles with 90-degree angles. And then we've learned about sine law. So sine law works for all triangles, whether they have a 90-degree angle or not. And today we're going to talk about cosine law, which is another method that works for any type of triangle. So it does not need to be a right angle triangle for you to use cosine law. So cosine law looks a little scary in the beginning, but once you get to know it, it's actually not so bad. So I have a triangle here. It is not a right angle triangle, and I also have an angle that is marked. So the key to using sine law and cosine law is we're always going to label our angle A. So if this is angle A, we're not labeling this time with hypotenuse or opposite or adjacent. We're just using letters A, B, and C. So across from angle A, you would find side A. So we're going to use a lowercase a to show that that's a side. And then you can pick one of the other ones. I'm going to call this one B. Across from angle B is side B. You'll notice I used an uppercase for the angle, a lowercase for the side. And then if I call this angle C, that's a capital C, and then across from that is a lowercase c for the side. So the formula for cosine law looks a little bit like the Pythagorean theorem. So if this is my angle A, we are going to start our formula with A. So it's going to be that side A squared equals side B squared plus side C squared minus 2 times B times C times cosine of our angle A. I warned you, it looks a little scary. Once you get to know it, it's not that bad. So I have A squared equals B squared plus C squared minus 2 times B times C times cosine of A. And the key to this formula is making sure that A is the angle that's given in your question or the angle that you're trying to solve for. So this week we're just doing side lengths, but next week we will be talking about how to find angles. So we need to try this out, see how it goes. So our first example says solve for x in each of the following triangles. Round your final answers to 2 decimal places. So up first, I have a triangle. It does not have a 90-degree angle in it, so I cannot use Pythagorean theorem or sine, cos, or tan ratio. It has an angle of 120. It has a side of 20 centimeters, one of 25 centimeters, and then a side x that we're trying to solve for. So when you're trying to tell the difference between when to use sine law or cosine law, to use sine law, you need to know an angle and the side across from it, which in this case I don't have, which is why we're going to use cosine law. So to use cosine law, I'm going to start by finding the angle in the question. And it's easy because there's only one of them. This angle here is the only one that I know, that 120 degrees. So I am going to call that A, right? A for angle. Across from angle A is my side A. That's the little lowercase a. Now your choice, doesn't matter which one of these is B and which one of these is C. So I might put B at the top, and then across from B is side B, and then I'm going to maybe call this one C, and then across from that is my side C. Okay, so when we do the formula, we always start with A. So A squared equals B squared plus C squared minus 2 times B times C times cosine of A. There's a lot of stuff in that formula, but you will find that the calculation is actually, I think, a little easier than the one for sine law. So A in this case is x. So x squared equals B squared. So B is 25. So 25 squared plus C, that's 20 squared, minus 2 times B, so times 25 again, times c, which is 20, and then times cosine of big angle A, which is 120 degrees. Okay, so the secret to this is doing this all in one step on your calculator, and do not press equals until you get to the very end. That's a big mistake a lot of people make. They like to hit equals after every calculation. Nope, you have to do the whole thing without pressing equals until you get to the very end. So we're going to do 25 squared. If you need to do 25 times 25, that's fine. I have a square button. If you want to use your exponent button, you do what you need to do. So 25 squared plus 20 squared, notice I'm not hitting equals, minus 2 times 25 times 20 times, and then you're either going to do cosine of 120 or I have to do 120 and then cosine. And at this point, I'm at the very end, I'm going to hit equals. And I get 1,525. Now, normally that number will be a decimal, and you will copy down every single last decimal place. Okay, so from here, I have x squared equals 1,525. So I don't want x squared, I just want x. To cancel out a square, I'm going to do the opposite and square root. So I'm going to take 1,525 and square root. And I get 39.05. That would be 2 decimal places. I'm going to take a peek at the next number. It's a 1, which means we're going to leave this as is. So it's going to be 39.05. So side x is 39.05, and then this is in centimeters. So the formula looked really scary, but if you have a scientific calculator and you just punch everything in, it's actually not so bad, right? So the trick is do not hit equals until you get to the very end, and then do your square root. So if you want to see another example, you can join me in the next video and we'll take a look at question B.